Hello, my name is Andrew Bohm, and this is my Lab 2 presentation for observing electric charges with pieces of tape. So I'm going to jump right into my introduction. This lab provides a more in-depth look at how neutral objects are polarizable and have interacting charges. The experiment from Lab 1 is reused, but this new model allows for a closer look at how individual particles interact and how a charged object, will consist of numerous and sometimes countless individual particles that are interacting. The main principle at play here again is Coulomb's law, observing the interactions of electrical charges. And in a preview of the results, my calculated total charge on the floating piece of tape was 1.73 times 10 to the negative 8th coulombs. And the key observation from this lab was that each particle on the tape experiences different electrical forces due to particles on the other piece of tape as well as other particles on the same piece of tape. This more clearly depicts the principle of superposition, which is very important in this lab. Our key principle here is Coulomb's law again, stating that the repulsive or attractive ability, which we call electric force, that one particle exerts on another is dependent on the magnitude of the charges and inversely proportional to the square of the distance between the two charges. The big difference here is modeling a line of individual charges rather than two individual point charges. The principle does not change, but now we consider multiple point charges superimposed around each other, with over a dozen point charges exerting electric force on each single charge. Newton's second law and net force equations and gravity are all still prevalent in this lab, but they have not changed from lab 1, and we're in physics 2. I think we all understand those pretty decently by now. Now to explain a little bit about my GlowScript model. This is a visualization of it, exported from GlowScript. Here we have the red dots operating as the charges on the floating tape, the purple dots operating as the charges on the bottom piece of tape, and gravity is represented by the big yellow arrow, which represents the total gravity from the center of the floating tape, and the white arrows represent the net electric force on each of the floating tape particles. Essentially, my model found the net electric force on each point charge from its superimposed particles surrounding it, and combined all of those net electric forces to solve for Q, which represents the total charge of the original piece of tape. My model solved that to be 1.73 times 10 to the negative 8th coulomb. In my model, I ignored air resistance. I assumed gravity and electric force were the only forces acting on the tape, and I had to assume that both pieces of tape had the same amount of evenly distributed charge. So for my experiment itself, it was the same setup as last time, two pieces of tape, view tapes with stuck together and ripped apart to create a charge. The top tape, the particles of the top tape are a system here. The surroundings are the bottom tape and earth exerting point charges and gravitational force on the top tape. There's my measurements of the top tape, and the most important measurement recording from physical recording is the separation distance of 0.033 meters, where the tape began to float. And here are my calculations showing my net force equation, my equivalence of electric force, magnitude of electric force being equivalent to the magnitude of gravitational force, how I calculated out magnitude of gravitational force and set that equivalent, and then how I manipulated the Coulomb's law equation to provide the point charge system, which will be useful in our following discussion of 1.1 times 10 to the negative 8th coulomb, and then showing my line charge for the top tape just as a comparison right there, 1.73 times 10 to the negative 8th coulomb, which calculated by my model. Okay, so here is my GlowScript code. I took my initial code from lab 1 and altered it to reflect the line point charges rather than two single point charges. You can see I have a function for the line charges, which will intake information about where the point charges are on the line and intake all of the electric field information from all of the other point charges in the surroundings in order to calculate the net electric force on each point instead of outputting every single electric force between all of the point charges on both lines. This basically utilizes superposition in my code, calculates the net force on each point, and then combines to find the total electric force and determine the total electric charge on the entire floating piece of tape. This other section of code just shows how I establish my arrows in the model image. Not as important here. So to discuss the what if questions, what if each of the tapes was modeled as a single point charge? Well, just like the first lab, the overall magnitude of the charge would be lesser. The point charge I calculated was 1.1 times 10 to the negative 8th coulomb compared to my line model of 1.73 times 10 to the negative 8th coulomb. Now these models differ because the line model compiles multiple point charges with net electric forces with an x component in the x axis, whereas the point model only has two charges separated at a set distance, my separation distance, in the y. And the line model is more realistic because it considers superposition of multiple charged particles that the pieces of tape consist of, rather than pretending it's a single particle for each piece of tape. And that's the end of my lab. Hope you enjoyed it.